Hi students, good morning to all. Grade 12 Mathematics. Today we will discuss about continuous of chapter number 2, inverse trigonometric function. Inverse trigonometric function. Last class we will discuss about trigonometric function and its graph, domain and range of the trigonometric functions, inverse functions and inverse trigonometric function. First one, y equal to sin x and y equal to sin inverse x. Inverse trigonometric function sin x is sin inverse x. So graph of y equal to sin x and y equal to sin inverse x. So today we will discuss about next second one, y equal to cos x curve and its inverse function, that is cos inverse x graph. Okay, design. Second one, first one y equals sin x and its inverse function is y equal to sin inverse x. Right. Second one, y equal to cos x. Y equal to cos x. You know the function f is bijective, then f inverse is exist, that is f is invertible. F is invertible. When f inverse exists and the function has only bijective function. Okay. So last class to say y equals sin inverse function, I have taken a principal domain of sin x function, that is a principal value of sin inverse x, that is minus pi, close interval of minus pi by 2 comma plus pi by 2. This is a range of the sin inverse function. Okay. Domain of sin inverse function is closed interval of minus 1 comma plus 1, and the range of sin inverse x function is closed interval of minus pi by 2 comma plus pi by 2. Right? Right. You know y equal to cos x curve. Domain of y equal to cos x curve. Listen, cos x is, here domain is R2 close interval minus 1 comma plus 1. Close interval minus 1 comma plus 1. Here R is a domain of this function cos x, and close interval minus 1 comma plus 1 is a range of this function cos x. Okay, right. Listen, you know the cos x curve. Draw the cos x curve. So cos 0 is 1 and cos pi by 2 is 0. You know cos pi by 2 and cos 3 pi by 2 are odd multiple of pi by 2 value, cos value is 0. Okay, listen. Now cos x curve is, this is cos x curve. This is cos x curve. Y equal to cos x 0. Cos 0 is 1, so 1. This is 1 comma 0. Cos pi by 2 is 0. So this curve is cut at x equal to pi by 2 and x equal to 3 pi by 2. Cos pi value is minus 1. So this is pi. Here minus 1 and plus 1. This is plus 1. Cos 2 pi. Cos 2 pi. This is cos 2 pi. Cos 2 pi value is plus 1 and cos 5 pi by 2 is 0. This pi by 2 and so on, etc. This is a cos x curve. You know a cos x curve? Listen. And y equal to cos inverse x. You say about cos inverse x. Cos x, here domain of cos x is a set of all real numbers and range is close interval of minus 1 comma plus 1. Right, inverse concept, you know inverse concept, the function is only bijective function. The function has bijective, then f inverse is exist. Not, the function is not only bijective, it's not 1 1 and on 2, therefore f inverse does not exist. So here y equal to cos inverse x. The cos inverse function is exists when cos inverse function cos inverse x exists when a domain is minus 1 comma plus 1 and the range of this function cos inverse x is 0 comma pi. 0 comma pi. So 0 comma pi is a principal domain. 0 comma pi is a principal domain of this function, or set of all real number is domain of this function cos x, but principal domain of cos x is close interval 0 comma pi. Close interval 0 comma pi. Listen, this interval 0 comma pi. This is 0, this is pi. This curve 0 to pi, 0 to pi. This is a principal domain. So 0 to pi is only principal domain. Okay, right. So the principal domain of this cos x function is 0 to pi. 0 to pi. So the cos x has unique value from the codomain in between 0 to pi. So we have the domain is x is belongs to 0 comma, so close interval 0 comma pi. This function y equal cos x is 1 1 and onto. 1 1 and onto. So whole interval, so x is belongs to R, that is set of all real numbers. Take domain is set of all real numbers. This function y equal to cos x is not 1 1 and onto, that is not bijective function. We restricted about the domain is principal domain. Take a principal domain 0 comma pi. Listen, the 0 comma pi, this function y equal cos x is 1 1 and onto, that is bijective function. Bijective function. Not only this one, this interval only, this function is 1 1 and onto to another interval pi to 2 pi and 2 pi to 3 pi, minus pi to 0, minus 2 pi to minus pi, and so on, etc. But we can take 0 to pi is a principal domain. Principal domain. So x is belongs to 0 comma pi. So here principal domain of cos x is 0 comma pi. This function cos x is bijective. Therefore cos inverse exists when x is belongs to 0 comma pi only. Cos inverse exists when x is belongs to 0 comma pi only. Here listen, y equal to cos inverse x. So cos inverse x is a function. This function related to minus 1 comma plus 1, close interval of minus 1 comma plus 1 to close interval of 0 comma pi. Here close interval 0 comma pi, this is range. 0 comma pi, close interval 0 comma pi is range, and minus 1 comma close interval minus 1 comma plus 1 is domain. So the domain of this cos inverse function is close interval of minus 1 comma plus 1, and range of this cos inverse function is 0 comma pi. Here 0 comma pi is a principal domain of cos x. Listen, 0 comma pi is a principal domain of cos x. But here 0 comma pi is a principal value of cos inverse x. Principal value, that is range. This is called principal value. Principal value. Listen, 0 comma pi is a principal domain of cos x function, but 0 comma here 0 comma pi is principal value of cos inverse function. That is this 0 comma pi, close interval 0 comma pi is range of this function cos inverse x. Okay, here domain is close interval of minus 1 comma plus 1. Change x and y axis. X and y axis values. Draw the cos inverse x. X axis, y axis. Here x value is 0, pi by 2, pi, 3 pi by 2, 2 pi. Here minus pi by 2, minus 3 pi by 2, minus pi, minus 2 pi, and so on, etc. But here x value is 0, 1, 2, 3, and so on, etc. 0, 1, 2, 3, minus 1, minus 2, and so on, etc. So this is 0, 1, 2, 3, 4, and so on, etc. Minus 1, minus 2, minus 3, minus 4. And y value have 0, pi by 2, and 3 pi by 2, pi 3 pi by 2, 2 pi, minus pi by 2, minus pi, minus 2, and so on, etc. Here, the cosinus of 0 value, cosinus of 0 value is 1. Cosinus of 0 value is 1. So, cos pi by 2 value is 0. Cos pi by 2 value is 0. This is pi by 2. So, the cos inverse x function is, this is cos inverse x graph. Cos inverse x graph. Y equal to cos inverse x. Here 0, pi by 2, minus pi by 2, minus pi by 2, minus pi. This is minus pi. Here minus plus pi. This is plus pi. Is 3 pi by 2 and 2 pi. 2 pi. And cos 0 is 1. Cos 0 is 1. Cos inverse of 0 is 1. Cos inverse of 0 is 1. And cos inverse of pi by 2 is 0. Cos inverse of pi is plus 1. Cos inverse of minus pi is minus 1. Cos inverse of minus pi by 2 is 0. Cos inverse of 2 pi is 1. So the curve, this is a y equal cos inverse x in whole interval x is belongs to R. But this is not a function. It's not a function in whole interval of this domain R. So we restrict the domain 0 to pi only. 0 to pi only. This interval only. 0 to pi. 0 to pi. Okay. So this curve only y equal to cos inverse x. 0 to pi. Listen. X, y. X, y. This is a y equal to cos inverse x. This limit is pi, here 0. This curve is y equal to cos inverse x. 0 to pi. Restricted about 0 to pi. Interval is 0 comma pi. So cos inverse x is domain is minus 1 comma plus 1. This is minus 1. This is plus 1. Plus 1. So here domain is minus 1 comma plus 1. And codomain is 0 comma pi. 0 comma pi. Sorry, codomain not. This range is 0 comma pi. The range of cos inverse x is 0 comma pi. This is the curve y equal to cos inverse x. Okay, very simple. Listen. This is y equal cos x curve. Here domain is R and codomain is, so range is minus 1 comma plus 1. Close interval of minus 1 comma plus 1. A principal domain of this cos x function is 0 comma pi. This is a cos x curve. Right. Next, y equal to cos inverse x. You know the cos inverse x definition. Domain is minus 1 comma plus 1 and range is 0 comma pi. So related minus 1 comma plus 1 to 0 comma pi. Here range 0 comma pi is called a principal value. This is the principal value of this cos inverse function. So the cos inverse function is the whole belongs to y is belongs to R. But this function is not, this relation is not a function. So we restricted the domain, this principal domain 0 comma pi. Here principal domain, but here 0 comma pi is principal value. So 0 comma pi, this is a principal value. Here domain is minus 1 comma plus 1. Therefore this function cos inverse x graph is 0 to pi. This is a range. Minus 1 comma plus 1 is a domain. Okay, very simple. This cos x function is inverse of this cos x function is x is when the domain is minus 1 comma plus 1 and the range is 0 comma pi only. Close interval of 0 comma pi only. Okay, right. Listen. Compared with the curve y equals sin x and y equal to sin inverse x. The y equals sin x curve. You know that y equals sin x curve is passes through 0 comma 0. This is y equal to sin x curve. Okay, so sin 0 0, sin 0 0, and sin pi by 2 1, sin pi 0, sin 2 pi 0. This y equal to sin x curve. Right, listen. Y equal to sin inverse x. Y equal to sin inverse x. So y equal to sin inverse x is also passes through 0 comma 0. This also passes through 0 comma 0. This is a y equal to sin inverse curve. This is y equal to sin inverse x curve. Okay, listen, these two curves, y equal to sin inverse x and y equal to sin x. So the y equal to sin inverse x is mirror image of y equal to sin x. Listen, y equal to sin inverse x is mirror image of y equal to sin x. Symmetric about y equal to x curve. Symmetric about y equal to x. This is y equal to x. So these two curves, y equal to sin inverse x and y equal to sin x, is symmetric about y equal to x. This curve y equal to sin inverse x mirror image of y equal to sin x, and y equal to sin x is mirror image of y equal to sin inverse x. Okay, right. Same. Next, compare to y equal to cos x curve and y equal to cos inverse x curve. Y equal to cos x curve and y equal to cos inverse x curve. Right, listen. Y equal to cos x. Y equal to cos x. X, y. X, y. First we draw y equal to cos x curve. This curve is very simple. So y equal to cos x is passes through 0 comma 1. This is y equal to cos x. Y equal to cos x. And y equal to cos inverse x. Y equal to cos inverse x. This passes through pi by 2 comma 0 comma pi by 2. This is y equal to cos inverse x. Y equal to cos inverse x. So y equal to cos inverse x is exist between 0 to pi only. 0 to pi. This is pi. 0 to pi only. So this curve is y equal to cos inverse x. This curve is y equal to cos inverse x. This is y equal to cos x curve. Y equal to cos x curve. These two curves y equal to cos x and y equal to cos inverse x is symmetric about the line y equal to x. Y equal to x. Though this curve y equal to cos inverse x and y equal to cos x is symmetric about the line y equal to x. A mirror image of y equal to cos x is y equal to cos inverse x, and also same mirror image of y equal to cos inverse x, y equal to cos x. In between the interval 0 to pi. 0 to pi only. Okay, right. Next third one, y equal to tan x curve and y equal to tan inverse x. Y equal to tan x curve. You know about y equal to tan x curve? Listen. Draw the curve y equal to tan x. You know that its domain is tan x is related to or set of all real numbers except 2n plus 1 into pi by 2. N is belongs to is it 2 set of all real numbers. Set of all real numbers. Here domain is set of all real number except 2n plus 1 into pi by 2. Except 2n plus 1 into pi by 2. And range is set of all real numbers. Range is set of all real numbers. Listen, this 0, pi by 2, pi, 3 pi by 2, 3 pi by 2 and 2 pi. Here minus pi by 2, minus pi, minus 3 pi by 2 and minus 2 pi, minus 2 pi. This is x-axis and y-axis. Right. 0. Listen. the curve y equal to tan x is not defined at x equal to pi by 2 and x equal to 3 pi by 2 and x equal to minus pi by 2 and x equal to minus 3 pi by 2 and x equal to minus 5 by 2 and so on etc. This odd multiple of pi by 2. Okay. So the curve tan x is passes through 0, 0. Here x equal to plus or minus pi by 2 and x equal plus or minus 3 pi by 2 and so on etc. X equal to 2n plus 1 into pi by 2 is asymptote of this curve y equal to tan x. Y equal to tan x. Here x equal to pi by 2 and x equal minus pi by 2 and so on etc. X equal to 2n plus 1 into pi by 2 and is belongs to z. This lines pi by 2 and pi minus pi by 2 and so on etc. These lines are asymptotes of this curve. Asymptote means this curve does not touch at any one point. Almost this curve touch at infinite. So infinite is not known. Okay. So this is y equal to tan x curve. Y equal to tan x curve. This y equal to tan x curve. Listen, y equal to tan inverse curve. Y equal to tan inverse x. Y equal to tan inverse x. Here, you know, principal domain of the tan x function is open interval. Principal domain of a function tan x is open interval minus pi by 2 comma plus pi by 2. This is a principal domain. Principal domain of this function. This is principal domain. Minus pi by 2 to plus pi by 2. Okay? Right. Listen. Draw the graph y equal to tan inverse x. Y equal to tan inverse x. This function here domain of tan inverse x is domain of tan inverse x is range of this function tan x. Here range of this function tan x is R. Range of this function tan x is R. So this function is R2 tan inverse x is related to R2. R is tends to here principal domain minus pi by 2 open interval minus pi by 2 comma plus pi by 2. Here the domain of this function tan inverse x is set of all real numbers. Set of all real numbers. The domain of the tan inverse x function is codomain of this tan x function. Codomain of this tan x function. So here R tends to minus pi by 2 comma plus pi. This open interval. Here my open interval minus pi by 2 comma plus pi by 2 is a range of this function tan inverse. Range of this function tan inverse x. Okay. So listen. Draw the curve. Here change x and y values. Here x values we take 0 pi by 2 and pi 3 pi by 2 2 pi and so on etc. Y is take 0 1 2 3 and so on etc. any real numbers. But here tan inverse x the domain is set of all real number and the range is minus pi by 2 comma plus pi by 2. So we get x value is set of all real numbers and y value is minus pi by 2 comma open interval minus pi by 2 comma plus pi by 2 1. Right? Listen. So x value is minus 1 plus 1. So plus 1, this is minus 1. Plus 1 and minus 1. Right. 0 plus 1 minus 1 plus 2 minus 2 plus 3 and minus 3. Okay. Right. Listen. 0 pi by 2 pi 3 pi by 2 and 2 pi. Here minus pi by 2 minus pi minus 3 pi by 2 minus 2 pi minus 2 pi. Correct. The range of this function is minus pi by 2 comma plus pi by 2. Minus pi by 2 comma plus pi by 2. So at x equal to pi by 2, this tan inverse of pi by 2 is not defined. Tan inverse of pi by 2 is not defined. So the line x y equal to pi by 2, sorry, x equal to pi by 2 is y equal to pi by 2 and y equal to minus pi by 2 and y equal to 3 pi by 2, y equal to minus 3 pi by 2, y equal to minus 3 pi by 2. Here the tan x curve is, this is a tan x curve. Here x equal to pi by 2 and x equal to minus pi by 2 is tangent to this curve. Here also same, y equal to pi by 2 and y equal to minus pi by 2, y equal to pi by 2 and y equal to minus pi by 2 and y equal to 3 pi by 2, y equal to minus 3 pi by 2 and so on etc. y equal to 2n plus 1 into pi by 2 is asymptote, sorry, it is not tangent, this asymptote of this curve. Right, draw this curve, range is minus open interval of minus pi by 2 only, so plus pi by 2 to minus pi by 2 only, plus pi by 2 to minus pi by 2 only. So this curve y equal to tan inverse x is passes through 0, 0. This is a y equal to tan inverse curve, y equal to tan inverse x curve. This curve is touch at x equal y equal to infinite points, or x equal to infinite points in y equal to pi. When y equal to pi by 2, x is infinite, y is tends to pi by 2 and x is tends to infinite. So x is tends to infinite. This is y equal to tan inverse curve, y equal to tan inverse x curve. So the limit is open interval minus pi by 2 comma plus pi by 2. Okay. Listen, domain of this tan x function is set of all real number except 2n plus 1 into pi by 2. Here domain of this tan inverse function is set of all real number, set of all real number, and range of this tan x function is set of all real number. But here the range of this tan inverse function is minus pi by 2 comma plus pi by 2 open interval. Open interval minus pi by 2 comma plus pi by 2 is range of the tan inverse x function. And also open interval minus pi by 2 comma plus pi by 2 is principal value of this function tan inverse x. But here open interval minus pi by 2 comma plus pi by 2 is principal domain of the function tan x. If the function tan x minus pi by 2 comma plus pi by 2 open interval is principal domain, the function is tan inverse x. Here my open interval minus pi by 2 comma plus pi by 2 is principal value, that is a range of the function tan inverse x. Okay, very simple. Right, next. Listen, next compare to the y equal cos x curve, sorry, y equal to tan x curve and y equal to tan inverse x. Listen, this is y equal to tan x curve, this is y equal to tan inverse x. So y equal to tan x and y equal to tan inverse x. This is y equal to tan x curve, y equal to tan x curve. So these two curves y equal to tan x and y equal to tan inverse x is symmetric about the line y equal to x, y equal to x. Listen, the curve y equal to tan x and y equal to tan inverse x symmetric about this line y equal to x. Here y equal to tan x is a mirror image of y equal to tan inverse x, and also same mirror image of y equal to tan inverse x is y equal to tan x, and symmetric about y equal to x line, y equal to x line, right?